Today we're going to look at the unit circle and the patterns that are in the unit circle. Remember the special right triangles that we started with. We looked at the 30, 60, 90 triangle, and we looked at the relationship between the sides of a 30, 60, 90 triangle with a hypotenuse of 1, that the side opposite the 30-degree angle was 1/2, the side opposite the 60 was the square root of 3 divided by 2, and the hypotenuse was 1. Looking at the 45, 45, 90 triangle, we learned that the side opposite the two 45s were square root of 2 divided by 2, and the square root of 2 divided by 2, and the hypotenuse again was 1. What we've done with these two special right triangles is we've put them onto the unit circle. The unit circle is drawn or superimposed on the XY coordinate plane, and we've divided each quadrant up into angles. The first angle in the coordinate plane, this angle right here, is 30 degrees. Now the distance between this angle to this one is 15. From here to here is 15, and from here to here is 30. So if this first angle is a 30-degree angle, and then we add 15 more, that makes this 45. If we add 15 more to that, that makes this angle 60. And then 30 more to that will make this angle 90. If we keep going around adding 30, we get 120, 30 more, 150, 30 more, 180, 30 more, 210, 30 more, 240, 30 more, 270, 30 more, 300, 30 more, 330, and finally 30 more at 360. Now we've done a complete revolution around our unit circle. Now in between the 30 and the 60-degree angle, because the distance from here to here is 15 degrees, that makes 5. 120 plus 15 more gives me 135. 210 plus 15 more gives me 225. And 300 plus 15 more gives me 315. So now we have all of our angles on our unit circle. The next thing that we're going to do is we're going to put on to the unit circle our radians. Now we could go through and we could just simply convert all the degrees to radians. And if you would like to do that the first time around, you certainly may, but I would suggest that you learn these using the patterns. So looking at the first angles that we put onto the unit circle, our 30 degrees and our 60 degrees, converting these to radians by multiplying the 30 degrees by pi over 180 gives us pi over 6. 60 degrees converts to pi over 3. 90 degrees converts to pi over 2. 120 degrees converts to 2 pi over 3. 150 to 5 pi over 6. 180 is pi. 210 is 7 pi over 6. 240 degrees is 4 pi over 3 radian. 270 degrees is 3 pi over 2. 300 is 5 pi over 3. And 330 is 11 pi over 6. Now the 45, I'm sorry, I forgot the 2 pi. 360 degrees is 2 pi. Now looking at this 45-degree angle right here, when you convert that one, you're going to get pi over 4. When you convert your 135, you're going to get 3 pi over 4. When you convert your 225, you're going to get 5 pi over 4. And when you convert your 315, you're going to get 7 pi over 4. So these are all your radians. Now what I would like for you to notice is that the denominators of the radians start with 6, and the only numbers that you have to learn are 6, 4, 3, and 2. Notice that you start with the largest number, 6, down to 4, down to 3, down to 2. Then if we look in the second quadrant, you will notice that it's a reflection of the first quadrant. This one ends with 3 on the denominator. This one begins with 3. 3, 4, 6. Notice how they reflect across the denominators. Then you have pi. Then in the third quadrant, your denominators reflect this second quadrant. If you end with 6, you start with 6. And then 6, 4, 3, 2. And then the fourth quadrant reflects the third quadrant. 3, 4, 6, and 2 pi. Now we're going to look at the numerators for those. Notice in the first quadrant, every numerator is just pi. When you get into the second quadrant, the numerator is 1 less than the denominator. 2 is 1 less than 3. 3 is 1 less than 4. 5 is 1 less than 6. When you get to the third quadrant, the numerator is 1 more than the denominator. 7 is 1 more than 6. 5 is 1 more than 4. 4 is 1 more than 3. And 3 is 1 more than 2. When you get to the fourth quadrant, if you take your denominator, multiply it by 2, and subtract 1, you'll get the number that's in the numerator. 3 times 2 is 6, minus 1 is 5. 4 times 2 is 8, minus 1 is 7. 6 times 2 is 12, minus 1 is 11. And if you can remember those three patterns, in quadrant 1, the numerator is just pi. In quadrant 2, it's pi plus a number that is 1 less than the denominator. In quadrant 3, it's pi and a number that is 1 more than the denominator. And in the fourth quadrant, it's pi and a number that is twice the denominator minus 1. Then you should have all of your radians. And now we're going to put on our points. For pi over 6, we have the square root of 3 over 2 and 1/2. The square root of 3 over 2 is the cosine, 1/2 is the sine. And we learned from what we did a day or two ago that this comes from the special right triangle 30, 60, 90. The sine is y and the cosine is the x. When we move on to our 45-degree angle, or our pi over 4, then we have the y is the square root of 2 over 2, which is the sine, and the x is the square root of 2 over 2, which is the cosine. Okay? When we get to our 60-degree angle, our pi over 3, then we have square root of 3 over 2 is the y, and the 1/2 is the x. That's the cosine. Now I hope you noticed as we went around that all of the denominators of 6 have the square root of 3 over 2 and 1/2. Denominator of 6, negative square root of 3 over 2 and 1/2. The cosine is negative because when we plot that point, we're going to go left and then up. Denominator of 6, negative square root of 3 over 2, negative 1/2. Both are negative because we go left and down. Denominator of 6, square root of 3 over 2, and negative 1/2 because we go to the right and down. The negative 1/2 is because we're going down. So if you have the denominator of 6, I always remember that because 3 times 2 is 6, that the cosine, the first coordinate, is the square root of 3 over 2 because it matches up with my 6. 3 times 2 is 6. When I'm looking at my pi over 4s, square root of 2 over 2 and square root of 2 over 2, every single point that has a denominator, every single angle that has a denominator of 4 is going to have the square root of 2 over 2 and the square root of 2 over 2. The only difference is that we have plus and minus signs depending upon which quadrant we're in. Here's the 7 pi over 4, square root of 2 over 2, and negative square root of 2 over 2. When you're looking at a denominator of 3, the cosine, the first coordinate, is going to be 1/2. I look at that because 1 plus 2 is 3. 1/2, square root of 3 over 2. Every single one that has a denominator of 3 is going to start with 1/2. And then the match up to that is the square root of 3 over 2. Same with 4 pi over 3, negative 1/2, negative square root of 3 over 2. Because we're in quadrant 3, we're going to go to the left first and then down to graph that point. And then in quadrant 4, 1/2, negative square root of 3 over 2. So, as a little wrap up to these points, what I do is look at the denominator. If it's a 6, I know the first coordinate is the square root of 3 over 2 because 3 times 2 is 6. If the denominator is a 4, I know that both of the coordinates are the square root of 2 over 2 because 2 plus 2 is 4 and 2 times 2 is 4. If the denominator is a 3, I know that 1/2 is going to come first because 1 plus 2 is 3. Now, these are not mathematical patterns really. I mean, they are mathematical patterns, but the way that I'm remembering them is just to help me. It's just a little mnemonic device to help me. 3 on the denominator starts with 1/2. 4 on the denominator, square root of 2 over 2. 6 in the denominator starts with the square root of 3 over 2. And that works every single time. Now, the only ones you have left are your quadrantal angles. And hopefully you know these because we've worked with them so much. The 0 or 2 pi is 1, 0. Cosine is 1, sine is 0. Pi over 2, 0, 1. Cosine is 0, sine is 1. 180, cosine is negative 1, sine is 1. And 3 pi over 2 or 270, cosine is 0, sine is negative 1. I hope this has helped you with the patterns for the unit circle. I'll get this uploaded to Edmodo so that you can use it to study for your quiz on Monday.